Hello guys, welcome back to my channel Medicinal Pharma Education. I hope you're doing well, preparing for your exams. And in the previous class, we have discussed the paper chromatography completely. If you have not watched it, go and watch it. In today's class, we are going to start with the thin layer chromatography. See, before starting this thin layer chromatography, like the paper chromatography, thin layer chromatography, ion exchange chromatography, and column chromatography are not quite important. The important one is gas chromatography and high performance liquid chromatography. You mainly focus on these two, then go with all these four. Okay, because majority of the questions asked in is HPTLC and gas chromatography. In every question paper, you can take one question from this and one question from this is sure. Okay, so that mainly focus on these two questions. Later on, these four questions. Okay, let us start with the thin layer chromatography. Okay, uh, TLC is the one of the simplest, fast, easiest, and least expensive of several chromatographic techniques used in quantitative and qualitative and quantitative analysis to separate organic compounds and to test the purity of compounds. See, the TLC is one of the simplest, fastest, easiest, and least expensive technique. Okay, it is used for both qualitative and as quantitative. Okay, it is used for separation of organic compounds and it for used for purification. Okay, let us start with the definition. The TLC can be defined as the method of separation or identification of a mixture of compounds into individual components by using divided adsorbent solid separated over a glass plate and the liquid is mobile phase. Take it out, only solid is used. Okay, see here what happens in the TLC, like we are using this method for separation or identification of the mixture of compounds into individual components by using divided adsorbent solid spread over a glass plate and a liquid as a mobile phase. I hope you have done your TLC experiment in your B form. There is like test also, right? In the TLC plate, you just identify it based upon the same. It is like in the M form also it is there. Okay. Principle, I'll just tell you the principle which I have written was little bit confusing for you guys, so that I've made like a new principle one. See the principle. The principle involved in TLC is adsorption. Okay, absorption means I said you right what is mean by why adsorption. When absorption is used, when the stationary phase is solid and the mobile phase is liquid, then we call it as adsorption. When the principle is based upon partition, what is the mobile phase, what is the stationary phase, just comment me and tell. Okay, just go now and just comment me and tell, so that I can understand you are understanding my concept. See, and we'll continue with the principle. The glass plate or the TLC plate is coated with suitable adsorb adz, uh, adsorbate. Okay, a silica gel to prepare the TLC plate, which acts as the stationary phase. Okay, next we'll start with the continue with our explanation. The compounds with more affinity towards stationary phase travel slower. The components with less affinity towards stationary phase travel faster. This is like a universal principle. In every case, you can see, like if the uh, components or the sample has more affinity, if it has more affinity, if example, if this is the solvent and this is the stationary phase, it has more affinity with paper, it moves slower. If it has like no affinity, it moves faster. That's the like simple principle involved in the TLC. In the chromatography itself, the compounds with more affinity, like they are like travel slower, with less affinity travel faster. This is the basic concept. Okay, the stationary phase, it is a thin layer of adsorbent, usually silica gel or alumina, coated on the plate. Okay, stationary phase is completed. Next, the mobile phase, it is a developing liquid which travels up the stationary phase, carrying the sample with it. The mobile phase, like in every mobile phase, what mobile phase does, it carries the sample in it and travels on the plate. Okay, it is until certain point. we call it as solvent friend, right? That's the same thing. The basic theory, we'll discuss the theory. The basic parameter used to describe the migration of TLC uh, is the RF value. RF means we will like find out the distance traveled by the solute by the solvent. See, distance moved by the solute divided by distance moved by the mobile phase front. Okay, this is like we will divide the total distance divided by will divide uh, the distance traveled by the solute by total distance. Okay, then we'll get RF value. Okay, it is called retardation factor. Now see here, what is retardation factor? It is the ratio of the distance traveled by the substance spot from the starting line to the distance traveled by the solvent front after correcting for a position of the solute liquid level. Okay, see what happens right here, the movement of the mobile phase on the glass occurs and it reaches the solvent front. At 75% we'll stop the experiment. Okay, we'll like remove the TLC plate. Okay, here just see this diagram. From this is the starting line, this is the solvent level, the plate is dipped. Okay, and from the here starting line from the water level to the solvent front, it is ZF, and from the starting line to the mark spot, it is ZS. Okay, and the distance starting line and the solvent level, the distance between them is N. Okay, sorry, Z0. By this we can calculate the RF value, Zs minus Zf minus Zn. Okay, by this we'll calculate the retardation factor. What is like the Zs, distance moved by the spot from the starting line. Zf, what is Zf? Distance moved by the solvent front from the solvent level, and Z0, distance from the solvent liquid level to the starting line. Okay, this is the of I mean the formula used. Okay, so it is Z0 or Zn, you can change the terms. Okay, this is the basic principle involved. Okay, by this we will calculate how much the solvent has moved. Next, factors affecting the RF value. I'll choose the camera for you. Factors affecting the RF value. There are many factors, but for your extra knowledge, you can, if you want, you can just read it, but it's not important for your exam point of view. The important part is here. Methods of application of adsorbent: pouring, dipping, spraying, and pouring, dipping, spraying, and spreading. Okay, like by the name only you can just tell the method. Pouring means like the liquid from the beaker is poured on the glass table. Dipping means we are dipping the glass TLC glass plate into the solution. Okay, next, spraying means by using the sprayer we are spraying it. Okay, spreader means we use the instrument to spread evenly. Okay, like this is the example, this is one instrument. We just a second, I'll just take my scale so that you can just understand it better way. See example, if you think this is the TLC plate, we will just pour at a corner and use this spreader to spread evenly. Okay, this is called spreading. That's it. That's the four concept. You can just read it, the spreading. This is the dipping, and just pause the video and just read it. Okay, or else the video will be lengthier, so I'll just not explain this. You have already studied it in your your B form. Okay, this is the spraying, and this is the spreading. So in spreading, moving spreader or moving plate. Moving spreader is nothing but plate will be at a stable state. We will move the spreader. This is the spreader. We will move like this. Okay, or the moving plate type means we'll keep the spreader in the same way. The plate is moved. Okay, the plate is moved from here to here. Okay, that's the moving plate type. So that the thickness is here, in the thickness can be maintained from 0.2 to 0.2 to 2 millimeter. Okay, this is the most used one. Okay, this is the spreading is the most used one in the industry. Next, activation of the plate. What is meant by activation? Okay, activation is nothing but drying. Okay, after spreading plates are allowed to dry in air or further dried and activated by heating at 100 degrees for 30 minutes. Activation is nothing but removing of the water. By removing the water associated with the layer completely, the adsorbent layer is activated. That's the activation. Okay, I hope you have understood. Next, we will go with the application. Okay, application of the sample. A sample solution in a non-polar solvent is applied. The concentration of the sample or the standard solution has to be minimum of 1% solution of either standard or test solution is spotted using a capillary tube or micropipette. You have seen the micropipette or capillary tube. By this capillary tube we will just spot out on the TLC plate. The area of application should be kept as small as possible for sharper and greater resolution. See, if see here, if this is the TLC plate, if we spot very small one, right, the if we are spotting here one and here one, the circle will become like this much. Okay, if we increase the amount of the solute here itself, the what I'll say, there will be merging of the two, this solvent and this solvent. Okay, then there will be no proper detection. For that we will keep the sample small. Okay, next, sample application. Okay, first draw a guided lines slightly with a pencil. See, after the drying we will just draw a simple line. Okay, and mark A, B, C, D. This is the capillary tube. Will place the solute, very little will place here in 3 places. Okay, this is the starting line and this is the plate 1 centimeter above from the edge, and we will finish the line 1 centimeter after reaching after the solvent front reaches almost to the 1 centimeter. Dissolve the solid sample in CH3Cl2. Use TLC capillary to transfer and spot the dissolved sample. Okay, that's the main process how we do. I mean, we can write in the stepwise also. First step is preparation of developing container. Okay, that the beaker will prepare. Next, prepare of the TLC plate. The plate is prepared. Spot again will spot the TLC plate. Development of the tank. Visualization of the spot. Development of tank is nothing but we will place the TLC plate and close the lid. Okay, they where the mobile phase travels from the type which on the type of the technique, based upon the type of technique we will discuss in next, where based upon type the moves ascending may be, descending it may be one directional, two directional. Okay, it may be there are several types we will discuss next. Okay, and we will last at what will do visualize the spot. Okay, these are the process. Next, what is there? See, development of the tank TLC plates. Okay, there are 6 mainly, max to max 6 there are there. If there are extra you just leave it. Okay, and they're not important. This is one dimensional TLC, means ascending or descending. Two dimensional TLC, horizontal TLC, multi or repeated evolution, and stepwise evolution. I'll just explain one by one. I'm ascending and descending and two dimensional. I know I hope you are seen my previous video. You can, if you have not seen, just go and see the previous video, you will understand better. Now I'll just explain in a shorter way. Ascending is nothing but the mobile phase is at the bottom and it moves from down to up. Okay, I'll just show you the diagram if it possible. Ascending chromatography. Then descending chromatography, the mobile phase is kept on the top, it moves from top to bottom. Okay, with the gravitational force. This is against gravitational force, this is with the gravitational force. Two dimensional TLC, I'll show you the image now. See, first the spot is placed at the edge, it moves in one direction and it is rotated and moves in one direction. Okay, maybe you're seeing this image. See, it's the compounds where the x is the starting point, and it moves to the top of the page, and we turn it to 90 degrees, and again we allow the mobile phase to travel. So it is called as two dimensional. Okay, two dimensional. Horizontal TLC is nothing but we place the TLC in normal we place it vertically. Okay, in vertically we place it. Okay, in vertically place, and the gravity also acts on it, but we don't want gravity to act, we place it horizontally. Okay, horizontally we place it. There is low, no gravity involved in the process. It is particularly based upon the traveling of the mobile phase. It is consistent, so that we will use horizontal. Okay, multi or repeated elution is nothing but, I'll just tell you, wait 1 minute, I have written here ascending, descending, or two dimensional, horizontal. Okay, horizontal. Next, multi repeated elution. I'll just tell you the process. Firstly, what we'll do, the repeated is nothing but we'll repeat the process, okay, until we get the result. That is called repeated or multi elution. Firstly, place the TLC plate in the mobile phase. The sample undergoes partial separation. Okay, this is the first process. Next process, what, we'll just repeat the same. Then again the TLC plate is placed in the mobile phase. Then also the sample separation occurs partially. Again, this is the second step, and again we will repeat the same. The sample is placed in the mobile phase, the separation of sample is completed. That is called repeated evolution. Okay, elution. This is repeated elution. And the next one is stepwise elution. Stepwise is elution. I'll just tell you the process so that you can understand. In the first step, place the TLC plate in the mobile phase first. Here we are using different types of mobile phase. In the first step, we'll use mobile phase 1. In the second step, we'll use mobile phase 2. In the third step, we'll use mobile phase 3. In the first step, place the TLC plate in the mobile phase. The sample undergoes partial separation. Okay, we will remove the mobile phase 1, and again we'll add the TLC plate in the mobile phase 2. Then also the sample separation occurs partially. Okay, and again we'll change the mobile phase. This is the third mobile phase. The sample is placed in the mobile phase third. The separation of the sample is completed. Until the sample is separated, we will be changing the sample polarity, or mobile phase will change the mobile phase, or this complete polarity will change, or the complete mobile phase is changed to get the results. That is called stepwise elution. I hope you have understood the 6 type. You can just list it out in exam. They will not ask particularly. If they have asked, you can just explain it in a short way. Okay. Next, detection. It is similar to the paper detection. The sample can be detected by using physical and chemical. The main drawbacks, I'll tell you. Physical, the chemical structure is retained, and the chemical is not chemically converted. Okay, in chemical method, the chemical substance is the sample is destroyed. In the physical, sample is not destroyed. Okay, the sample substance is not being converted into another substance. Okay, we just detect by using the instrument UV method, refractometer, radioactive technique. Okay, in the chemical method, what it happens, we spray the chemicals on it, so it shows the color, but it will lost its nature. Okay, it will lose its nature. Sample nature is lost. We can't get the sample out of it. In the physical, we can get the sample. The substance is created chemically or by applying reagents. It is converted into another form for detection. Nitrine, potassium, ferricyanide, many chemicals based upon the mixture you are selecting. We use the reagents. And application last. Applications are very important. Okay, you should know, if you don't want to focus on the application, just you should know what the chromatographic applications. Okay, they are almost similar. Purity check, component identification, reaction monitoring, separation of mixtures, drugs testing, food testing, plant analysis, quality control. This, by this we will complete the TLC. Okay, in the next class we will start with the ion exchange chromatography. If you like my lecture, please like, comment, and please subscribe. This will really motivate me. Thanks guys, see you in the next class. Take care, bye.